All right, number 5, a bowling ball encounters a hill, as seen in the diagram here. On the way back to the ball rack, so this is the one where the ball comes back to you. Ignore frictional losses, see the mass. Translational, that's linear, or you can see it with the units, meters per second at the bottom. So I know down here the velocity is 3.5 meters per second. Find the velocity at the top. Again, interchanges of heights, a great strategy is try using energy. So energy at the beginning plus work non-conservative equals energy at the end. Well, I have to say height equals 0 is at the bottom. Right? So at the bottom, it doesn't have any potential energy. It has linear motion, so it has kinetic energy. It has rotational motion because it's rotating. Work non-conservative. Gravity is conservative. We said rolling friction is also conservative, so that's not there. So what else is happening? Well, the next thing that's happening is we go to the top. At the top, I have a height, so I have a potential energy. Is it still moving? Yep. So I have a new velocity. Make sure to label that as such. And I also am going to have a new rotational energy. All right. So what have we done in the previous problems? We've converted all rotational to linear. So this needs to now become 1/2. Well, this is a bowling ball, so we have been saying this is 2/5 mr squared times v over r squared, so that squared cancels. So on this side of the equation, I got 1/2 mv squared plus 2/10. So 1/2 plus 2/10. I feel like I should know this. We've done it enough. That gets me 7/10. As you can see, my little work up above there. Right? So on the left side of the equation, I have 7/10 mv squared. Right? Now, that velocity is known. Mass isn't known, so I sure hope it cancels. On to the right side of the equation, I don't know that velocity. I need to get rid of this. This needs to end up being rotational, so that's going to end up being the same thing. So I have mgh plus 7/10 mv2 squared, because I have a new velocity. Now, from here, we can see masses cancel. After this, I believe you know all the variables. So 7/10. The velocity in the problem is 3.5 at the bottom squared equals g, which is 10. The height is 0.76 plus 7/10 v2 squared. Do some algebra and solve for v2 squared. Sorry, v2. I get 1.18 meters per second. Before I even check the answer, let's see if that's reasonable. What's going to happen? As the ball goes up, okay, I am going to lose kinetic energy and gain potential, so I have to have lost a velocity. Let's double check now. Is number 5, I believe we had 1.18, and there we go, 1.18.